Welcome back, everybody. In this video, we're going to be looking at the treatAs function and how we can use it to create a virtual relationship. Now, virtual relationships are great for when you either can't have a regular relationship or it just makes more sense to not have one. So, without further ado, let me go sketch it out for you right now. Okay, so here we are with not a whole lot. So let's add something, shall we? I'm going to start by adding a data model, right? So this is the pretty simple data model we're going to be working with. We have two tables, a goals table and a geo table or geography table. On the goals table, we've got one row per sales goal, or some kind of goal, I guess, right? And we've got some amount in millions, so 60 million, 20 million, 30 million, right? But we just have 60, 20, and 30 in there. And we've also got the sales region associated with each one of those dollar amounts, North America, Europe, and Asia. Now, on the geo table, we have not one row per region, but one row per country. So all these geographical, countries, right? Why didn't you call it the countries table? Because geo only had 3 letters in it, right? So really, the geos table or country table, whatever we want to call it, we got one row per country. And we've got that country's code, USA, Canada, Mexico, UK, France, China, and India. The label for that country, what region they belong to, North America, Europe, or Asia, as far as our sales are concerned anyways, and whether or not they have a sales office. So we can see that we've got a sales office in the US, right there, we've got one in Mexico, and we have one in India, right? So note, before we go too much further, that we cannot have a relationship between these tables, right? Because this table here, which is fundamentally a dimension table, has one row per country, and our goals are not at the country level, but they're at the region level, right? We can, as humans, infer a relationship between region to region, but we can't just drag and drop and create one in Power BI. Not without doing many-to-many, and that comes with its own problems, which is a good flag that we're going to do a virtual relationship. Okay, so this is the data model we're working with, right? Let me go ahead and add the sort of longer names for these different columns, right? So these are the way that they would appear in Power BI if you were to go to the data viewer. But when you're typing in the names of the columns in the code, they'll actually look a lot more like this. So the full name for office in the geo table is this right here, geo office. The full name for region in the geo table is, geo region. So the full names contain sort of the local name, right? What the sort of short name of the column is. But the full names also include at the beginning which table they come from, geo or in this case goals region. Okay, good. So as I mentioned just a second ago, I got ahead of myself there, right? We can infer as humans a sort of relationship between these tables based on region to region. Each goal here is tied to a region, and we can see the regions over here. But because this table is at one row per region, it's one row per country, we cannot have a regular relationship. One other option would be to create a snowflake table where we've got a geo table, and then over here to the far left, we have a region table, and we tie goals to that far table over here. But that's a lot of stuff. It's complicated, and also this video is about using treatAs to create a virtual relationship. So why don't we go ahead and do that approach, right? It may vary from solution to solution, but here I'm going to show you the virtual relationship version, right? Virtual relationship approach. Okay, so there's our data model. What else do we have? Well, we have our end result as it would appear in Power BI. So what we want to create is a measure that is our total sales goal measure, right? And we also want to have this slicer over here that will slice to whether or not we're looking at places that have a sales office or places that don't, okay? Now, where do we get this 90 million right here? Well, let's not think in terms of DAX just yet. Let's just think in terms of humans, right? How would a human go about this problem? Well, we've got North America, Europe, and Asia. And if we look over here in our geo table, we could see the different regions and whether or not they have a sales office. If we look at North America, it has 2 sales offices, right? If we look at Asia, it's got 1 sales office in India. If we look at Europe, there are no sales offices. So knowing that if we filter down to office equals yes, we're looking at North America and Asia. We should be looking at the North America row here and the Asia row here, but we should be ignoring Europe because Europe does not have a sales office, right? Not 1, not 2, not 100. It's got 0 of them. So we should just be looking at 60 plus 30. So 60 plus 30 is 90. And also, we're going to do a little bit of pretty basic math to convert these dollar amounts, which are just in like, 60 and 30, and convert those to millions. So 60 plus 30 times 1 million is 90 million. That's how a human being would get that answer. Let's see how we can arrive at it with some DAX, right? And here's the whole measure. We're going to build this thing up piece by piece, but this is what the finished result will look like, right? In a quick nutshell, right, we're going to use this treat as function to go get a list of all the regions and convert it to a table that will act as a filter on goals, add that as a filter, and then once we've got that filter for the regions we want to look at in place, we'll use this SUMX to go get a list of all the visible goals, which should just be one for North America, one for Asia, and then take each one's amount, multiply it by 1 million, and add them up. Now, if that sounds kind of complicated, don't worry, we're going to do it one piece at a time. Okay, so let's just sort of put that away for a second, right? Oh, actually, that's not what I'm doing. I'm going backwards on the slide deck. Don't put it away just yet. We're not done yet. Okay, so what I want to do now is create our initial filter frame, right? So when we're doing DAX sketches, we understand our different evaluation contexts as these frames, right? These aren't things that actually exist in the code, but they're ways for us to represent concepts of evaluation context, row context, and filter context. So when a measure evaluates, like total sales goal, it's always going to evaluate within a given filter context, or a starting filter context, sometimes called an initial filter context. So when we run total sales goal down here with this slicer in place for office equals yes, we're going to sketch it out, we'll draw our frame here representing our initial filter context. And what's going to be in there? Well, the initial filter context will have one filter for yes, because that's what the user clicked on in the slicer, right? And that's it. Now, in terms of DAX sketching, we will draw our temp tables out like this as a rectangle, where we have what's in that temp table, the value yes, which column it's based on. It's based off of the geo office column, because notice yes right there for office. This is the geo office column. And the temp table that's going to act as a filter there in the filter context is a 1 row by 1 column temp table. Now, if our data model was a lot bigger, I wouldn't be able to show you what the actual temp tables look like. Because our data model is nice and small, I can actually just draw you a picture of them, right? So in a DAX sketch, I would render it out like this, but the actual temp table looks like this. So when I click on yes for office, what's really happening is Power BI, and actually more specifically the DAX engine, is going to create a temp table that looks like this, based off of the geo office column with one value for yes, and when that's in the filter context, that will act as a filter for geo office equals yes. Okay, so let's go ahead and keep going, right? So basically what we're saying here is with this initial filter context, we're going to take the formula here, or to be more very technical, the expression, I just think of it as a formula, but the formula here, and we're going to run this in this initial filter context. So all the stuff we typed in our formula, that's going to run in this filter context. Okay. Now, we're going to do a lot of stuff in here, but there's almost too much. Let's go ahead and kind of erase all this, and just build this one piece at a time. So what's the first thing we're going to do, right? The very first thing we're going to do down here, well, we're going to start by taking the values of the geo region column, okay? So what does that look like over here? Well, it's going to look like this. So values is a snapshotting function. Anytime you get data out of the data model, we call that a snapshotting function, right? It goes and pulls data out of the data model and into a temp table. And this particular snapshotting function is going to go get all of the visible values, right? That's where you get the word values for the name of the thing, right? From whichever column we tell it to. And we're saying go look at the geo region column. Now that's geo region right there. So the values function looks at the geo region column and gets all the distinct values. But when it does it, it's going to pay attention to the filter that's in place. And right now we have a filter for office equals yes. So if there was no filter for office equals yes, we'd get North America, Europe, and Asia. But because we've got that filter in place, we're not looking at all the rows. We're just looking at that row, office equals yes, that row right there, and that row right there. So if we're just looking at those, we've got North America, Asia. Well, North America will just appear one time. Values doesn't bring back duplicates. And we'll also have Asia. So the resulting temp table will look like this, right? I would sketch it out like this, where I would say what's in it. Well, the values of North America and Asia are in it. It's on the region column of the geo table, and it's a 2-row by 1-column temp table. Because our data is nice and small, I can actually draw it for you, like actually show you a picture of the thing, right? So the values geo region snapshot will return a temp table that looks like this. It's on the geo region column because that's what we pointed it at, and it's got the values of North America and Asia because those are all of the visible values that are distinct if we pay attention to the filters that are in place. Okay, good. So that's all well and good, but we have a bit of a problem, right? We don't want to filter the geo table, we want to filter the goals table. And right now, if we added this as a filter, it would correctly filter the geo table, but that's not what we want. We want to filter the goals table. So we need a little bit of trickery. And that trickery is going to arrive in the form as the treat as function. So we're going to take the results that we just created, this guy here, right? And we're going to pass it into the treat as function. And what is treat as going to do with it, right? Well, treat as is also a snapshotting function similar to values, but it behaves a teeny bit differently. We do give it the column we want to look at in the data model. Notice this time it's not geo region, but goals region, right? Goals region right there. And what is it going to do? Well, right, it's going to take the temp table that we provide as the first argument, this one right here, and it's going to go look for these values in whatever column we told it to look in, right? So it's going to go look for these values in goals region, right there. So let me be a bit more specific about that, right? So we take the initial temp table that we add as argument 1. That gives us the values that we want to look for, right? And then we have to tell it where do you want to look. We'll go look in the goals region table right there. So it's going to go look for North America and Asia in the goals region table and bring back a temp table that has those values. And it's going to look like that right there, right? So the temp table that pops up also has North America and Asia, just like before. This time it's based on the goals region column, right? Not geo region, but goals region. It's still 2 rows by 1 column, okay? So if you were to look at these two temp tables and not look very closely, you would say, oh, they're the same temp table. They're both based on some sort of region column. They both have North America and Asia in them. And that's, an okay guess. But if you look closer, you say, well, wait a minute. Nope, this one is based on the geo region column. And this one is based on the goals region column, right? So in some ways, it's almost as if the treat as function, it basically takes this temp table that we created right here and almost just sort of renames the columns. It's a little more complicated than that, but in practice, that's how you could think of it, which is where you get the name treat as. We basically want to take this temp table and treat it as if it were based on the goals region column. And sure enough, we get a temp table that looks like this that's going to be treated as if it's based on goals region, because it is. Okay, so what's important about this, right? This version over here that we already established, it can act as a filter on the geo table because it's on geo region, right? But it cannot act as a filter on the goals table because we don't have a relationship between these tables. By contrast, if we look at this temp table over here, which is based on goals region, this can act as a filter on the goals table because it's on a column of the goals table, specifically goals region right there. So if we were to add this as a filter, it would filter down this table, which is exactly what we need to do. So let's see how we do that. Okay? So we've got all our stuff down here. What are we going to do with it, right? We're going to take the results of what we just did and pass it into the calculate function as argument 2, right? So this is all the stuff that we built right here. That's over there. We pass that into calculate as argument 2. So what does calculate do with it? Well, what does calculate do in general? Calculate, we call it a framer, right? And basically what it's going to do is it's going to create a frame within a frame, or a modified filter context is another way you might describe it, right? So what does that look like? Well, so calculate will take the existing filter context, create a new frame within a frame, right? And then make some changes to that filter context. So we have new filters to work with, right? Now, right now, all we have is a copy. We just took that filter for a yes and added it. But what else is calculate going to do with it, right? Well, that is where this temp table comes in. Keep in mind, we passed in the results, right? Treat as all this stuff as argument 2 of calculate. So we're taking all this stuff over here and giving it to the calculate function. And what is calculate going to do with it? It's going to add it as a filter. Just like that. There we go. Okay, so when you give the calculate function a temp table, like we did right here, it will take it and add it to the new filter context that's being built, right? So out here in the initial filter context, in our initial frame, we just had a filter for office equals yes. Now in this new frame that we built, we have a filter for office equals yes still, right? That one came along for the ride. But now we've got this new filter for goals region equals North America and Asia, right? Out here it was just a boring temp table. When we give it to calculate, calculate kind of promotes it, and then it's going to start acting like a filter, okay? Okay, so that's all well and good, right? That's all well and good. But let's do a bit more formal sort of explanation of calculate, right? So what does calculate do? Calculate creates a new filter frame with a modified filter context within which it runs a new filter formula. So this is the new frame that we built, right, with our new filter context. And argument 2 was the filter that we wanted to add, right? But what about argument 1? Notice it's kind of blank right now. That's going to be a problem if we try and run this thing. Okay, so argument 1 is the new filter formula, And look, this is our new filter formula. This is the sub-formula that we want to run in this new frame that we just built, right? So whatever we type in for argument 1 of calculate, that's going to run as a sort of sub-formula, right? A sub-expression if you want to be fancy, here in that new filter frame. So all the stuff we typed in for argument 1, that's going to run in here, okay? Now, as I alluded to a second ago, you may have not heard this called the new filter formula before. You may have heard a term like the sub-expression of calculate, which is technically very accurate. That there's a reason that people use that term, but that's a little tricky for new folks. The basic idea of an expression is already kind of hard, let alone a sub-expression. So for me, when you're learning, I prefer to call this the new filter formula, a sub-formula, right, that runs with new filters in place. Okay, so let's go ahead and kind of pull some of this stuff back. And this is all well and good, but there's almost still too much stuff here. So let's do this one piece at a time. Okay, let's sort of go back a second. So what's the first thing that we're going to do in our new filter formula? Well, we're going to start off by taking the auto snapshot of the goals table, right? So what does that look like over here? Well, when you type in the name of a table, right? Oh, that should have an S on it. Sorry about that. Should say goals, which is the real name of the table, not goal. When you type in the name of a table in the data model and you don't wrap it in a more specific snapshotting function like all or values or something like that, or all selected, what it will assume that you want to do is to go get all the visible rows of that table in the data model and add them as a temp table, right? So because we're pointing at the goals table up here and we've got these two filters in place, this will produce a temp table where we apply the filters for GeoOffice equals yes and goals region equals North America and Asia, right? Now, because there's no relationship between these tables in the data model, the filter for office equals yes is over here on the geo table. It'll have no effect on what comes back. By contrast, the filter for North America and Asia, that is on the goals table, right? That's why we created it up here, so that it would be on the goals table, specifically the region column in the goals table, right? So this will act as a filter and just show us the North America and Asia rows. North America and Asia. So what do we get back? We're going to get back that row and that row as a temp table, and it will look like that, right? So we sketch it out. We say we get back the visible rows of all of the column of the goals table. That's what that little star means right there. This is going to be 2 rows by 2 columns, right? I got a little plus there because there's some advanced stuff that we could talk about later on. But basically, it's going to be 2 rows by 2 columns, right? And notice we get the North America row and the Asia row. Why didn't we get the Europe row? Oh, because we have a filter in place for North America and Asia on the goals region table. So we basically explicitly say, don't look at Europe, look at North America and Asia. So now we've got a temp table that looks like this, where we have North America for 60 and Asia for 30. What are we going to do with it, right? So we've got that temp table with the visible rows. How do we actually produce the number that we want down here? Well, we're going to pass this into the SUMX function, right? SUMX is an iterator. What we mean by that is it's going to take the temp table that we give it, this one right there, that one right there, same one, right? And it's going to iterate over it. Well, what does that mean? Well, let's actually look at this thing, right? So SUMX will take the temp table that we give it and create a set of row contexts. One context per row, right? So we've got 2 rows here in our temp table. We're going to end up with 2 row contexts. Let's see what those look like. And we're going to start with the bottom one, right? just because the top one's going to go on top and we won't be able to see the bottom one. So for our bottom row right here where we've got Asia and 30, what happens is the SUMX function will create a row context that looks like this. In our DAX sketches, we draw this out as a card that'll show up in a deck of cards, right? And this is the bottom row context where if we take this row for goals region equals Asia and goals amount in millions equals 30, it'll create a row context with those values in it, right? Goal region equals Asia and goal amount in million equals 30, right? So that's the bottom row context, right, for that row right there. And then it'll create an additional row context for the row directly above it. And it'll look like this, right? So our bottom one was back there, and here's our top one where we've got, goal region equals North America and goal amount in million equals 60. Goal region equals North America, goal amount in M equals 60, okay? So great. So the SUMX function creates this set of row contexts, one row context per row in whatever temp table we give it. But why? Like, what's the purpose of this? This seems silly. Well, what happens next is that we take this set of row context, one row context per row, and then what we will do is we will run a per row formula in each row context. And that's where argument 2 of the iterator comes in, argument 2 of SUMX in this case. So whatever we type in for argument 2 of SUMX, this will be yet another example of a sub-formula, a per row formula at this time, that runs both for this row context and this row context. So whatever we type in for argument 2 of SUMX will run in this row context, in this card here, and the exact same formula will also run back there, right? And we're going to run the same formula for each card or each row, and we're going to get a different answer. We're going to get a different answer because we're running those same formulas in different row contexts. Specifically, these reference for goals amount in million. In this row context, that points to the number 60, and back here it points to the number 30, which is the amount in millions for Asia as opposed to North America. So let's actually see that. Okay? And to help out a little bit, just to really emphasize this, I'm going to kind of just block off this other elements of the code just so we can focus on the iterator itself, right? So SUMX, we gave it this temp table that gave us the temp table to split into row context, and here's our per row formula to run in each one. So let's see what running it actually looks like, okay? So on the top row here, this reference to goals amount in million, that points to a current row value in the row context. So the row context basically says, hey, all the values of the current row, those are essentially going to be named values that you can get by just typing in their name. So in your per row formula, you can get either of these values, either North America or 60, by typing in the name of the value. So this text string for North America, that's named goals region. And this number 60, that has the name of goals amount in M. So this reference to goals amount in M, that goes and looks in the row context for something called goals amount in M. Well, yep, there it is, goals amount in M. What is that? That equals 60. So this turns into $60. And then the rest of our formula is multiply that by a million, right? I added commas here, which aren't in the original formula, just to make it easier to see that we're multiplying it by a million. So we take 60, we multiply it by a million, and what do we get? We get 60 million. That is our answer. For the top card, the row context for North America. Okay, so we've got that 60 right there. Let's go look at the card behind it, shall we? Okay, now if we look at the card behind it, right, we start with the exact same per row formula, right? So for this row, we're going to run this sub formula right here, where we take the goal amount in M and multiply it by a million. Now, in the previous card, the previous row context, goal amount in M pointed to the number 60, but in this row context, which is corresponding to this row right here, that reference points to the number 30. Goals amount in M equals 30. So when we run this sort of step by step, the first thing that happens is that reference to goals amount in million, right? Again, I'm missing the S on the reference there. Sorry about that. These should all say goals, right? Goals amount in million, that brings back the number 30, which then we can multiply that by the number 1 million, and we get 30 million, which is our answer for the bottom card, right? So for the top card, we got 60 million. That's what you get when you run the per row formula in the top card. And here in the bottom card, when you run that exact same per row formula, because it runs in a different row context or runs with a different set of values of the current row, we get a different number, in this case 30 million. Okay. So we've got our two cards, and we've got an answer for each one of them. When we run that per row formula on each card, we get two answers, 30 million behind, 60 million up front. What do we do with it? Well, keep in mind, this is all happening inside of the SumX function. So the SumX iterator, when it runs the per row formula on each card, once it gets all the numbers, it's going to sum them up. Well, what does that look like? Well, we had the number 30 million from the back card and the number 60 million from the top card. 30 million plus 60 million, what does that equal? Well, that equals 90 million. And if you're paying close attention, this is actually our final answer, right? And so that is how we arrive at the actual solution that the DAX engine shows up with, right? Okay, so what I want to point out here, the most important part of all of this, all the iteration stuff is interesting. The stuff that's new here, and particularly interesting, I guess, is this stuff up here. So let's sort of rewind a little bit. The stuff that makes all of this work, is from this step way back here, right? Going way back a little bit. The part where we got a snapshot of the region table, got a list of regions to look at, North America and Asia, based on the filter of this column here. Then we use the treat as function to create a new temp table based on a completely different column, but with the same values, with the exact same values. And when we have that temp table there, then we can use the calculate function to add it as a filter, which makes everything else work, which is why it gets the name virtual relationship. We have no real relationship between these tables, but using the treat as, we could go get a list of regions from one table, this one over here, and then sort of convert it to a list of regions on a different table, creating a virtual relationship. Okay, I sure hope all of that was helpful, and I will see you guys in the next video.